Welcome to page 3 of the periodic table packet, which deals with metals. Okay, again, in the following pages you'll learn about nonmetals, right? You have to know differences between metals and nonmetals in order to understand the next packet. Okay, so if you don't know what a metal or nonmetal is, you're going to be lost in the next packet. Alright, so this page is strictly with metals, right? We're going to teach you the physical and chemical properties of metals and where they're located, right? And some tricks to memorize them. Alright, and basically when you learn about nonmetals, it'll be the total opposite of metals. Okay, first thing is look at your periodic tables. You'll notice this staircase here. Ever see it, the red line here? This is the staircase. That's what they call the staircase. And on your reference tables, you can see it's a bold black line, shape of a staircase, right, located in the same position. Right, all the elements located to the left of this staircase. All of them to the left. So if you look at this entire periodic table, all the way to the left, it's about 2/3 of the periodic table. So 2/3 of this whole periodic table are metals. So the only element that's not a metal that's to the left of the staircase is the one stuck up here, of course, by itself, hydrogen. Right? But everything else to the left of that staircase is a metal. Okay, so that's the first thing. Right? So you learn the 3 L's. The first L is left. Okay, so number 1, I want you to write the following. Make up 2/3 of the periodic table and are located to the left of the staircase. Make up 2/3 of the periodic table and are located to the left of the staircase. Okay. Now let's focus on this, on your reference tables. Look at all these elements to the left of the periodic table. All right. I'll zoom it in a little bit. You can leave the camera over there. Zoom in a little bit. Okay. Notice the oxidation numbers. Again, here's your staircase. All left. Look at it. Are they all positive or are they all negative? These are all positive oxidation numbers. All right. And go all the way over to the left. Everything is positive. I don't see any negative oxidation numbers anywhere. Everything is positive. Positive 1, positive 2. We have positive 2, 3, and 4. Everything is positive. So what did you learn previously about positive ions? When an element forms a positive ion, or an atom of an element forms a positive ion, are you gaining electrons or are you losing electrons? You're losing electrons. So if you have a +1 ion, you lost one electron. If you have a +2, you lost 2 electrons. All right, so that's what metals want to do. Metals want to lose electrons. They don't want to gain electrons. Metals want to lose electrons. When you lose electrons, you're forming positive ions. So that's going to be number 2. So number 2, write tend to lose electrons and form positive ions. Tend to lose electrons and form positive ions. All right. Number 3, you should be familiar with already. All right. Before you write it down, let's take an example of what you learned previously. We'll stick with Na. All right, sodium atom. All right, so Na, a sodium atom. Let's go back to electron configurations. Remember, sodium atom means no charge, just Na by itself, no charge. The electron configuration is 2-8-1. Okay, so that means, you should already know what that means. You draw an atom, there's the nucleus. It means you have two electrons in the first shell, 8 in the second, and 1 electron in the valence shell, the outermost shell. Okay, so now when sodium forms an ion, it's going to lose 1 electron. So you lose 1 electron, you lose that 1 outermost electron. You lose this 1. So when you form a sodium ion, Na+1 ion, you're left with 2-8. So now how many shells do you have? 2. Only 2. So you have 2 in the first, 8 in the second. When you lost that 1 electron, you lost the whole third shell. So this is what a big Regents topic. What they always like to ask, they like to want you to compare the size of an atom with an ion. You have to know this for metals and nonmetals. All right. So in a metal, which is bigger, the atom or the ion, and why? Okay, in all metals, the atom is always larger than the ion. Right, because when it forms an ion, it loses electrons. It just doesn't lose electrons, it loses an entire shell. All right, so the ion in a metal, the ion is always smaller than the atom because the ion has 1 less shell than the atom. All right, and another way to remember this is atom ends with the word M. metal begins with the letter M. So then I just circle the M's. All right, so atom, metal. So that's how you memorize. In a metal, atom is larger than the ion. Okay, that's what you write for number 3. For number 3, write in a metal, the atom is larger than the ion. In metals, the atom is larger than the ion. Then also add this in for number 3. Atom, metal, circle the M's. Okay, so next to examples, you can write Na is larger than Na plus 1. For examples, you can write Na is larger than Na plus 1. Okay. Another example, you can do Ca is larger than Ca plus 2. Right, because Ca is 2-8-8-2. That's 4 shells. Calcium loses 2 electrons when it forms ions. You get 2-8-8. Now you have 3 shells. So those are 2 examples. Na is larger than Na plus 1, and Ca is larger than Ca plus 2. Okay? So you got to know that. Okay? Very important. And then I wrote a question there. Why are the ions of metals smaller than their atoms? You're going to write, because the metal ion has 1 less shell than its atom, because it lost electrons when the atoms formed ions. Let's say that again slower. Because a metal ion has 1 less shell than its atom, because it lost electrons when the atom formed ions. Okay? So just know, why is the atom bigger in a metal? Because it has 1 more shell. The ion is smaller. Why? Because it lost a shell when it lost electrons. Metals lose electrons. Okay? All right. So remember, I mentioned the 3 L's. That's our second L, is lose. So the left of the staircase, first L is left, second L is lose. Okay? You have to know metals, atoms larger than ion. Okay. Okay. Number 4, what I mentioned about the file cabinet. Be hammered into sheets. Where is that? Malleable. So number 4 are metals are malleable. Write that for number 4. Metals are malleable. Okay, so anything to the left of that staircase is malleable. Number 5, metals are ductile. It means they can be made into wires. Number 5, metals are ductile. All right. Number 6, metals are good conductors of heat. Metals are good conductors of heat. Then write thermal conductors in parentheses. Thermal conductors means conductor of heat. Metals are good conductors of heat, thermal conductors, and good conductors of electricity. Then put electrical conductors in parentheses. So metals are good conductors of heat, thermal conductors, and good conductors of electricity, electrical conductors. How are we on time?
8 minutes.
8 minutes? Okay. And, all right, so 7, 8, and 9. Number 7, remember what I mentioned before, right? If metals want to lose electrons, so it's going to take very little energy to pull the electron away, so they have what? Low ionization energies. That's the third L, low. So number 7 have low ionization energies. Have low ionization energies. And number 8, they don't want to gain electrons, right? So they have very low electronegativity, so let's get that out of my face. So number 8, have low electronegativities. Number 8 have low electronegativities. Okay, and the last thing, which metals are the most reactive? The further left you go and the further down you go, the more reactive you are. All right, so everything in group 1 is more reactive than group 2. Let's look at Li and Ra. You know Ra is all the way at the bottom and Li is at the top. Li is more reactive than Ra because it's further left. Then as you go down, you get more reactive. Na is more reactive than Li, K is more reactive than Na, and so on. Rb is more reactive than K. So the most reactive metal is francium, Fr. So number 9, I want you to write the most reactive metals are found in the lower left region of the periodic table. The most reactive metals are found in the lower left region of the periodic table. Lower left region. So remember, left, low, lose. Now, answer the questions on the bottom page 3 through page 4 and page 5. All the questions from pages 3 to 5. And you'll see the answers on your next video. This concludes this video.